Here it's asking how many moles of O, or oxygen atoms, are needed to combine with 0.212 moles of carbon atoms to form CO in part A and separately CO2 in part B. So if we look at part A first, so we want to make CO, which is a 1-to-1 ratio of carbon and oxygen. If you draw the Lewis structure, if you did this one on the lab experiment, you have a triple bond there so that both atoms can make noble gas configurations. Gives you a formal negative here, a formal positive here. The question is how many moles of oxygen are needed to combine with 0.212 moles of carbon. Okay, so there's a couple different ways to approach this. The easiest way is to think about the information given to you when you're given a formula for a substance. And when I'm given a formula for a substance, I use that formula to tell me how many of each atom there is combined together in that unit. I have 1 carbon and 1 oxygen. Right? So let's say I asked you, I want to make a bunch of molecules and I only have 5 oxygen atoms. How many carbon atoms would I need to match up with those to make molecules? It'd be 5, right? Because I need the ratio in the formula calls for 1 carbon for every 1 oxygen. So this formula can be thought of a relative number of items that I need of both things. I need 1 oxygen for every 1 carbon. A mole is a number of things. So because my formula tells me if I wanted to make 1 molecule, I need 1 carbon atom and 1 oxygen atom, right? So you can think about the formula in this way. If I wanted to make 1 unit of that substance, I need 1 of each atom. If I wanted to make 1 mole of CO, since a mole is just a number of things, to keep the same 1-to-1 ratio of carbon, I would need 1 mole of carbon and 1 mole of oxygen. So the question says, how many moles of oxygen are needed to combine with 0.212 moles of carbon? Well, in this formula, I can say a relationship for every 1 mole of carbon, I need 1 mole of oxygen. Right? The formula gives me the ratio in number of atoms per molecule. It also gives me the relationship in moles, because the mole is just a number of things. And if I need an equal number of carbons for every oxygen, I need equal numbers of moles of oxygen for every carbon. So you can see that the answer here is 0.212 moles of oxygen for every 0.212 moles of carbon, since the ratio calls for an equal number. But you could also set up a conversion. You could say, how many moles of oxygen do I need for 0.212 moles of carbon? And then you would just use this as a relationship. It won't always be a 1-to-1 ratio. It just happens to be a 1-to-1 ratio here, so it's easy to do the math in your head. But if you have 1 mole of carbon for every 1 mole of oxygen, because the ratio is 1 to 1, then those units cancel and you have 0.212 moles of oxygen that you need to combine with an equal number of moles of carbon to make a compound with the ratio of 1 carbon to 1 oxygen. In part B, if you're looking at CO2, now your molecule has 2 oxygens for every carbon, so when you draw the Lewis structure, you'll realize you need double bonds on either side to make the noble gas configurations. now I have a different substance. In this new substance, for every 1 carbon, I need 1 oxygen. So one relationship would be to say 1 atom of carbon requires 2 atoms of oxygen. Or I could say 1 mole of carbon requires 2 moles of oxygen. Right? The formula gives me the ratio of the substances involved in either individual atoms or in moles of atoms. And so if I want to know how many moles of oxygen do I need to combine with 0.212 moles of carbon for CO2 versus CO, then I would use the formula for CO2 and get the relationship from that. So this should be moles of carbon. So that relationship would be here, and I would say for every 1 mole of carbon, I need 2 moles of oxygen. So that would be 0.424 moles of oxygen needed. So knowing the formula of a substance here is really helpful, right? You can use that to calculate the molar mass and get the ratio from the periodic table for how many grams there are per mole of the substance. It tells you how many atoms of each substance you need to make 1 molecule. It tells you how many moles of each substance you need to make a mole of molecules. It gives you the information you need to draw a Lewis structure, which then you can use to determine polarity and start to talk about how these molecules might interact with one another and attract one another, and you can use that to say something about whether they'll have dipole-dipole attractions or London forces, and if so, what type of boiling point or melting point will they have, what state of matter will they likely exist in at room temperature.